Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have seen how to solve a non-linear partial differential equation where the power or degree of p and q was 2 or greater than 2. Let us take few more examples of the same type in this video. Let us take the first example for this video. So we have p plus q is equal to 1, where p and q are the standard definitions. P will be del z by del x and q will be del z by del y. Let us start with the solution. The general solution, the standard form what we write always is, this is our equation number 2, and as usual our question, that is a given linear partial differential equation, is our equation number 1. Now we know that p and q are partial derivatives of z with respect to x and y respectively. Let us find the partial derivatives of z from this equation. Partial derivative of z with respect to x for this equation is a, which is equal to p by standard definition. Similarly, partial derivative of z with respect to y will be equal to q. Let us find the answer from this equation. So substituting values of a and b as the values of p and q in equation 1, we get, which further implies, substituting this value of b in our general solution of z, what we get is, so now we have got the general solution, that is z is equal to ax plus 1 minus a into y plus c, that is equation number 3. This is our general solution. To find a singular solution, we will be requiring two partial derivatives of z and we'll equate them to 0. The first one will be, so we equate del z by del a to 0, and the second part we equate. Now, before we do this, we need to substitute c also as a function of a. So we will put c is equal to a function of a in our equation number 3. So we finally get z as, now let us find del z by del a. Our equation number 3 was, therefore we substituted c and we got, therefore del z by del a will be, correct, derivative of psi a, which will be equal to 0. Now we get the another part, partial derivative of z with respect to c. For this, we'll be differentiating the initial equation, that is z is equal to ax plus 1 minus a into y plus c. If we differentiate this, what we get is, this part will become 0, this part will become 0, the last part will give us the derivative 1. But even in this case, we have to equate it to 0. So we should ideally be equating this to 0. But 1 is not equal to 0. So this particular case signifies that this particular question does not have a singular solution. So you can write at the end, this partial differential equation does not have a singular solution, correct? So this itself will be your final solution. Friends, let us move to the third example, the second example of this video. The question here is p plus sine q equal to 0. Let us solve this partial differential equation. We know that by definition p and q are partial derivatives of z with respect to x and y respectively. Now, so what is our z? Here, let us assume our general solution to be our equation number 2, and the question will always be our equation number 1. So let us find the values of p and q by partially differentiating z with respect to x and y respectively. So now let us find the values of p and q by partially differentiating z with respect to x and y respectively. So p is equal to del z by del x, which will be equal to a. So p will be equal to a. Similarly, we will find the value of q. To find the value of q, we differentiated z partially with respect to y. We got the answer as b. So q is equal to b. Substituting the values of p and q as a and b in equation 1, we get this. Finally leads us to the value of b as, substitute this value in the general solution, we get the value of z as, this will be our final general solution for the given partial differential equation. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.